Welcome everyone. This is the third video of my coil winder video series. In this video I'm going to show you how this thing works and what is left to improve or finish. So in my previous two videos related to this project I showed you the mechanism and I also showed you how I assembled the electronics. However, that is a slightly changed thing in this video, but the core thing, which is the microcontroller, is the same. And then in this video I will show you a demonstration about this thing, so how it works, what can you do with it, and how the quality of the coil looks like after winding. So it will be a quite simplified demonstration, and I will just explain these things, what you can see here. More serious reveals about the structure and the source code which is on the microcontroller will come in another video, because otherwise this video would be very long, and I know that people are not watching my videos more than 5 minutes, so it doesn't matter if I make a long video because people are not watching it. So let's start with the mechanism here, and as you can see the most conspicuous things are these stepper motors. They are NEMA 17 stepper motors with slightly different torque. This stepper motor belongs to the main shaft, and I will refer to this shaft always as a main shaft, also in the source code. So the main shaft has the reel or spool or bobbin, however you call it. So basically you wind the copper wire on this thing. At the end it will look something like this. Of course it will look nicer because I winded this with my hands. So the copper wire will end up on this thing, and then we have the secondary shaft, which I call feeder shaft, because the wire comes through this thing here, and it feeds the wire to this coil here, which is being made. So this is the feeder, and while the main shaft is continuously rotating in one direction, the feeder goes back and forth, or left and right, because it helps to feed the wire to a certain location on this reel here. So when you want to have the wire on the left side of this coil, then this will be like closer to the left side, and then when you want it to be on the right side, then it will do like this. And basically that's the most let's say advanced thing about the software I wrote for the microcontroller and all these things, that based on the dimensions of the bobbin, and based on how many turns you want, what is the wire diameter and so on, and what speed you are using, the main shaft will turn with a certain RPM that you can program, of course, or not program, but give it as an input value. And then based on that everything is calculated, and for example, if we are looking at this bobbin here, then the feeder shaft will oscillate back and forth and help the wire to end up at the correct spot. So then this is totally programmed, and it works quite nicely, so I will show you that. And then yeah, we have this aluminum frame. These are wheels, so I can turn them, and the role of these wheels is that they give some sort of tension to the wire, because we have the wire here, as you can probably see it, and what I have here is sort of a screw, and this screw, or this nut, is screwed on a bolt, and then this bobbin here with a large amount of copper wire is squeezed in between two thrust bearings. So that like squeezing gives some sort of tension, because there is some friction here, and when this wire goes through the system like this, I try to show it. So when the wire is coming like this and being pulled by the main shaft, then there is a friction in the system, and that friction provides the tension to the wire, and it works to a certain extent. But for example, one of the improvements that I have to do is to replace this system, and I have already ordered some things which can help me to improve this system, but yeah, they are on their way, so it will take some time. But this is how the wire is being fed to the main reel here, that we have a reel of wire here, and it can be any kind of reel, of course. Here I'm using 0.35 millimeter diameter wire. It's coming from this reel. I just put it on another smaller one. And then, so it's starting here. I have roughly 200 turns on this one. And then it goes under this and over this. It goes into this tube, which is actually covered with a Teflon layer inside, so it will not kill the wire, the enamel on the wire. And then it comes out of this nozzle, which is just a copper nozzle with this tiny hole on it. This has a 1 millimeter hole, but when I was testing this, I discovered that when I tried to pull the wire back, I completely removed the enamel from the wire, so it might not be the best idea to use this kind of feeder. So I will also think about the improvement of this thing. But this is what we have on the mechanical side. And on these sides, or on this side of the structure, we have two regular bearings just to support the shafts. And yeah, this shaft has 8 millimeter pitch, so one turn on this shaft will result in 8 millimeter linear displacement. And this is just a regular linear rail with some carriage here with bearings in order to support this feeder thing here. So this is all. And then the electronics part is basically nothing else than just we have a microcontroller here. It's buried under the cables. It's an STM32 blue pill, and then it's connected to this LCD. We have two buttons, which is either up and down or start and stop. This could be familiar to you if you follow my other videos and you saw my stepper motor control panel, because I borrowed that kind of design and implemented it in this control panel. And then we have the rotary encoder here, and this rotary encoder is without any switches, so I just added a button separately, and this does the same function. And in the video where I showed you the electronics for this, I actually showed some easy driver stepper motor drivers, but then I thought that the current that they provide might not be enough, especially for the main stepper motor. So I went for the DRV8825 stepper motors. I have this nice breakout board, as you can see. So each stepper motor has its own board, and that's all. And then I have this common power supply through this power jack here, 2.1 millimeter jack plug, so it is compatible with these universal power supplies. So that's what we have there, and basically that's the whole system. So first I just put back this wire so we don't grab it or catch it by accident. And what I'm going to do first, I just show you how this moves without any kind of wires, and then we go and test it with a wire. But I can tell you right now that the coil which is produced is not perfect, or will not be perfect. And if you are following my Instagram, I already shared one attempt, and that was quite successful until I almost finished the second layer. And then there was a jump in the wire, so one thread was skipped by some reason, and then that messed up the rest of the coil. But let's connect everything and see what happens with this thing. First of all, I just start with the control panel, because that's enough for us right now. So we have a welcome message, and then what we can do, we can set up the speed. This is in steps per second, and I'm using 400 steps per turn micro-stepping with both of these stepper motors. So this means that we have 5 turns per second or 300 RPM. So that's quite a high speed for making a coil. So I will decrease this speed. So I just enter this menu, and then I keep the button pressed, and that decreases the value here by 40 at each iteration. So you can see that it goes down quite fast. So we go down to 400 steps per second, which is 1 turn per second or 60 RPM. That should be enough. Acceleration, that can be left untouched. Turns, so this is 200, but I will decrease this. I have some numbers in my head, and this should be roughly 185, and that will result in roughly 5 layers on this bobbin, and I tell you why. So then the wire diameter, this is one tricky topic, because this actually has the enamel on it, and the nominal diameter of this thing is 0.35 millimeters, but that's not correct. It's closer to 0.37, 0.38, so I keep it 0.37, and we will see what happens. And then pitch, this is not yet implemented, so now I put the wires right next to each other, but the pitch would be when you have a certain gap in between the turns of the coil, but this is just in the menu, and it can be modified, but it doesn't do anything. So this is not yet implemented. It will be implemented in a future project. So the bobbin width is just the width of this part, and either you can measure it or I can tell it to you, but just to have it measured, I grab this nice caliper, and it's 14 millimeters. So we modify this, and this is important because everything which is controlled here is calculated mathematically. So we do not measure anything, we calculate everything, and that when I will explain the source code in the next video, I will show you how this is calculated, because actually when you come up with all these equations and everything which controls the motors, then you have the full control over your stuff. And I happen to know the diameter, that's 12 millimeters, and that is important when you want to measure the consumption of the wires. So actually, based on the number of turns and the diameter of this reel, you can calculate the consumed wire length, and that's very nice. So the main shaft, this is just the position of it, and then the feeder shaft is again just the position. So from this 0 position, which we set up manually pretty much, then we can see how much steps are done. And then this is the auto winding. So there are a few information here, layers left. So in real time you can see how the winding is going, but it's not updated very fast, but you will see how it is updated. And then the turns done is technically how many turns are done on the main shaft, and then the length is updated a bit less frequently, I think at every layer. That is the length of the wire which is already consumed. And then we arrive to the first menu again. So we will enter this part, and I put on the power supply. And what we want before we start, and actually before we put the power supply on, we want to align the nozzle when we have the wire here, of course. Now I will show it without for the first demonstration. So we want to align the nozzle with the side of the bobbin here, so then the stepping of this part will start from where it should start, and then it will go in that direction, and then it slowly will feed the wire to this bobbin, which is actually clamped by these two nuts and these two, let's say, additional nuts. So these are just counteracting these inner nuts, so they will not get loose when everything is rotating. So now I will tell you what will happen. So this will start to move. It will accelerate to one turn per second quite quickly. And while this is doing the turns, this will go back and forth, I think 5 times, because we are building 5 layers. And now I show it without connecting the wires everywhere. So what we will see is that this shaft is continuously turning, and this feeder goes back and forth. So everything is put together. So I just press the start and we will see what happens. And everything will be in real time. I will not speed it up, so we will see. So this is going, and you can see that this part started to go that direction. And when it reaches the side, the nozzle, then this will bounce back. But this is purely number based and not based on any switches or positions. So now it reached the edge, and now it goes back. And how this is moved is based on the width of this, which we measured. So this shaft has to travel 14 millimeters in one direction, then it will be turned back to the other direction. So this was all. It was very noisy, and it is very noisy, so I think I will just stop doing this, because it doesn't do any use other than being very noisy. But what would be more exciting is to show this with a wire. So I will attach a wire, and then we will see how the coiling works in real time, basically. So I just assembled the whole thing. And what we have is that there is a hole here. I already put everything together, and I don't want to disassemble it right now. But what we have is there is a hole here, so I will try to pull the wire through that hole, and that will help us to hold the wire in place. So here is the wire, and I just leave like 3 centimeters, let's say. And firstly, I use the washer, if I can get it free, and I push the washer against this wire to make sure that it's like flat. And then I put on the, let's say, primary nut. Then I just, with hand, I tighten it. And then I put on this next, let's say, fixing nut. Then I use this wrench to tighten it a little bit more. And now what we have to do is we have to do the first turn manually, just to nicely align the wire. So what I do here is that I'm just holding this thing to have some kind of friction, and now I just try to pull this wire and make it as close as possible to the wall of this bobbin. And meanwhile I also align the feeder so it will go where it should go. So I completed one turn with my hand, and this is fine now, so everything should be in order, hopefully. So what we have to do is we check our numbers. So we will go one turn per second, so this will be slow and loud, and 185 turns, so it should be 5 layers. And hopefully, or not hopefully, but in this video, hopefully we will see how this thing fails. And then we have the wire diameter, which is the 0.37 millimeters. On this reel we have 0.35, but I think that that is the diameter without the enamel, because I can measure it with this thingy, this screw micrometer, and I think it will not give any different. 36. So I think I more believe 37, because sometimes this is also like deformed, and then that gives a bit larger gap between two turns of the coil here. So this is fine, and I tested it with 0.37 and it was quite okay. Pitch is not implemented. The width, we measured it previously, and that was 14 millimeters. This is the width, and that is the travel distance for this. So when the code knows that 14 millimeters was completed in one direction or the other, then it will just flip the direction, and it will do it as many times as many layers we have. Diameter, this is the diameter, 12 millimeters. I measured this earlier, not in the video, but I know that that is 12 millimeters. This is neglected, and we are here. So then I will power up this by connecting the power supply, and after powering up the things, I will press the start button, and we will see how the coil winding develops. And once again, this goes 1 turn per second, so it will be slow. So I might speed up the video during editing, and when something bad happens or good happens, I will slow the video down just to make it more visible to you. So power is on. And I just press start, and we see what happens. So I stopped this because it's messed up. So I will fix this, and we will run the test again, because this became loose for some reason, and the bobbin was not fixed enough in the beginning of the experiment, so the whole coil got messed up. But that's why we do the experiments, to learn from the failures. So I will fix this in a few minutes, and then I will show you again from the beginning. So I put everything together, and I hopefully tighten these screws enough. I will hold this with my hand because I might need to adjust the friction here by hand. So we will see. So I pulled back all the wire here. We only have completed one full turn here by hand, just to have the initial alignment. And now what I will do is that I press the start button again, and we will see if we will fail again or not. But before that we need the power supply, obviously. So let's see now. So this was it. There were a few hiccups at the end, which I don't know why happened, but it happened. So we completed the 185 turns, and we consumed 8.5 meters of wire. That's not so bad. So the problem is that yeah, everything started to fall apart here, and when the tension disappeared for a moment, Then during the second layer, everything got messed up, and you could see that then the whole set of wire just got totally demolished, so it's not so nice anymore. But yeah, as you could see, it works. The electronics works very nicely. I'm quite okay with that. It moves the motors properly, and I can go up to quite high speeds and so on. So that is okay for me, but I still have a lot of problems with the mechanism, especially with the tensioning. But as I said, I already thought about an idea which should work better than this thing here, and I will implement it in the next step of this, let's say, coil winder. So this was all for this video. I just wanted to show you that there is a certain progress, of course, and now the machine works. I just have these yeah, smaller or larger mechanical issues. So once I sort them out, I will come back to you and show another update. Maybe it will be a bit more professional looking thing, because actually the program or the software itself is working very well. I tested it several times and it works reliably, but something is not good with the mechanism still. So I will have to work on that a bit more than the software part here. So I hope that this video gave you some ideas if you want to build your own things. Please don't forget to visit my website, because you might find some other resources for this or for other projects which are related to stepper motors or microcontrollers and so on. So please do that. And then I hope you learned something. I hope this video was useful to you, and see you in the next video.